All right. So matrix multiplication. All right. So yesterday we saw with matrix multiplication, or adding, subtracting, and then the scalar multiplication. But with the adding, subtracting, particularly the dimensions of the matrices really mattered. You had to, they had to be the same size in order to add or subtract them. It's a little bit different here today, but the dimensions are still critical, but it's not as simple as with just the adding, subtracting. So this time, though, being the same isn't the key, being the same size. Yesterday, being the same size was what was important. So in fact, some matrices that are the same size, you actually can't multiply them. So I'm gonna make up a word here. They're not multipliable. Okay. Pleasure. So being the same size does not mean that you're going to be able to multiply the matrices to each other. Okay. Pleasure. What does matter is that the number of columns in the first matrix is equal to the number of rows in the second matrix. So that's how you know if the problem can be done. And then we're going to talk about how we figure out what the dimensions of the product are. Okay. So can you do the problem, and then how big is the answer going to be? And not what is the answer, but how big is the answer going to be? And we're going to start off by looking at the way these matrices with a bunch of variables in them, just a bunch of letters in them. That way, I think sometimes when you look at them with numbers, when the numbers do the math that they do, you lose track of where they might have came from. But if you do it with a letter, the letter doesn't ever go away. It's just, it stays there, so it doesn't get hidden. So I just want to start off looking at it with letters first, then we'll get down to doing an actual problem here eventually. But we're going to start off just with some letters first. So something I mentioned to you guys yesterday when we were doing the adding, subtracting problems was, I was labeling them with how big they were, and then I was like putting a check mark between them and saying, hey, you don't actually need to do this, but you do need to be checking, but you don't need to write it down. Today I'm going to tell you that you really do need to write down the dimensions. It's going to be pretty much imperative that you do that. So as I look at that first matrix here, it's got 1, 2, 3 rows and 1 column. So that's a 3 by 1 matrix. And the second one has 1 row with 2 columns. That's a 1 by 2. So in order to be multipliable, the number of columns in the first matrix has to be equal to the number of rows in the second matrix. So the second number here has to be the same as the first number here. So what's nice about when you write them like this is that you just look at the middle 2 numbers. Those have to be equal. If they are, that means we can do the problem. Okay, so this problem we can do. Well, how big is the answer, you say? I heard you all say it. Okay. The answer will be a 3 by 2. So we take a 3 by 1 times a 1 by 2. The answer is a 3 by 2. Okay. Nope. Yeah, Brian asked if it was because of the ones. Nope. It's always those outside 2 numbers will tell us how big the answer is going to be. So the inside 2 will tell us if the problem can be done. The outside 2 will tell us how big the answer is. Okay? Every single time. So what you need to do right after you figure out how big the answer is going to be is you're going to set up a work matrix. Now, you're going to have a work matrix, and then you'll have an answer matrix. So you're going to set up a work matrix, and it needs to be a 3 by 2 matrix. So a 3 by 2, so that means 3 rows of 2 columns. So oops, 1 row. So when I say work matrix, you're going to need to give yourself space. And I actually think it would be good for you guys to make little lines. Right? So there's one row with 2 columns. Then I need another row with 2 columns. And I need another row with 2 columns. I would suggest you make those actual spaces, draw those lines, because you need to know that you have 6 spaces to fill. Okay? A 3x2 matrix will have 6 empty spaces in it. If you don't make those little lines, you're going to lose track of how many spaces you're supposed to fill. Okay? So I really would suggest you actually draw those lines, make that work matrix. And then we'll have a little answer matrix where we can condense things into a smaller picture when we're done with it. But just want to give yourself some space to work. Don't try to smush it all in. Okay? So that's just kind of setting it up. Now we're going to go back and talk about how do we actually go and do the work. So this is actually a very small problem that we're about to do. So you guys won't see all of the interactions that are really there yet. Okay? Well, on the next one, we'll see a little bit more of what happens. But because, and it really is because of these ones, because these are ones, we don't see so much yet. We'll get there. Okay? So what happens, the idea is that you take that first row here, that first row needs to multiply the first column. Okay? Well, the first row only has one thing in it, and the first column only has one thing in it, so we're not doing a lot. Right? Which again, I said this is kind of a small problem because they're both ones. So the first row times the first column will give me my first row, first column spot. So that math is going to go right here. The first row times the first column go right here. So of course, a times x is just ax. So that, the whole first row times the whole first column would go here. Well, now I'm done with that column, so I'm going to move to the next column. So I'm going to go away from the x, move to the y. So I'm staying in that first row, but now I'm going to move to the next column. So the first row times the second column will give me my first row, second column spot element entry. So a times y will go here. I don't have anything more in that row or in that column, so that means I'm done with that. Again, this is a small problem. Now I'm completely done with this row, which means now I'm done with this row. So that A is done. Now I'm going to reset, but instead of looking at A, now I'm going to look at B. That row needs to multiply this column. So second row times the first column. And the only thing there is the b and the x. So those are the only 2 things that are going to multiply. So b times x is bx. That's everything that's in that row. That's everything that's in that column. So that means I'm done with that spot. So I'm going to move to the next spot, which means I'm going to move to the y. So b times y, of course, is just by. I don't have any more spaces in this row, which means I'm done with this row. So I'm going to go down to the next row and reset. Now I'm looking at C, and C is going to need to multiply the first column. So the last row times the first column will give me my last row, first column spot. So of course C times x is just cx. That's everything that's in that row and everything that's in that column. So I move to the next column. And then C times y. So again, this is a very simple problem. There are a lot of things there, but we didn't have to do much because each row only had one thing in it, and each column only had one thing in it. So we don't have the next step, which we'll see on the next problem. So the actual answer would look like this. You guys don't necessarily need to write this because it is just going to be a repeat. We're not going to be able to change anything. But you can just kind of condense things down so it's not so big. So there'd be our answer. We're not solving, we'd be simplifying. So, if that was a 3 and then that was a 2, we'd say that that would be 6. And, if that was a 3 and then that was a -5, then we'd have -15. Okay, I just wanted you to see where the numbers came from, though. If it's a 6 and a 15, it's not always super clear where they came from. But we can see where the A came from. We can see where the X came from. Okay? Now we're going to mix in some numbers and letters. Again, we'll still be able to see where they came from. Okay? So the very first thing you do is look at the dimensions of both matrices. So this is 1, 2 rows, 1, 2 columns. So it's 2 by 2. 1, 2 rows, 1, 2 columns. This is also a 2 by 2. So I mentioned that just because you're the same size does not mean you're multipliable, okay? But you can be. What matters is, are the two numbers in the middle the same? So these are. That means we can do the problem, okay? Then you look on the outside, and that tells you how big your answer is. So this is a 2 by 2 answer. So 2 by 2 times a 2 by 2 gives us another 2 by 2. Okay? Not anything to memorize or anything like that, just happens. So I'm going to create a 2 by 2 workspace. So 2 rows of 2 columns. Again, I would really recommend you guys draw those lines. You know you need to have 4 maths here when you're done. Okay? We had to have 6 maths here to be done. And it's kind of like doing the arcs on the foil. Make sure you don't miss something. Okay? This one's going to be a little bit, we're going to see more of what's supposed to happen here. Okay? You take that first row times the first column. Okay? And I wish you guys were all here so I could do this up on the board in front of you and so you guys could watch how I'm moving my fingers around. Okay? And so you guys are going to have to look up at me. You guys are going to have to, at home, or try to watch this. Okay? So that 1 is going to hit the A. Okay, so it's 1 times A. So I take in 1 times A, and then I take 2 times C. So as my left finger moves to the 2, it moves right, my right finger moves down. So I go from 1 to A, 2 to C. And if there was another one, I would shift more to the right and more down. Okay? So you have to get this pattern of movement with these. That's really what it is. The key to this stuff, guys. It's how do you move through the rows and the columns? Okay? So with my left finger, I'm always moving to the right. With my right finger, I'm always moving down. Okay? So I start off with 1 times A. So of course that's just 1A. And then I add the next thing. So I move to the right, 2. I move down, C. So 2 and C. So 2 times C. So 1 times A plus 2 times C. My first row and my first column give me my first row, first column spot. All of that has to go there. All of that is from the first row and first column interacting. There they are. There's nothing left in that row to multiply anything left in that column. So that spot is done. So I'm now going to move to the next spot, which means I'm going to move to the next column. I go back here. So now I'm looking the first row times the next column. So I put my finger on the 1, I put my finger on the B. I got 1 times B. I'm doing that, and I'm saying that because I think that's a good idea for you guys actually to do. Go over there and point at the 1 and the B, and then you're going to drag your finger to the right to the 2. You're going to drag your finger down to the D. So 2 times D, and then those will add. I don't have anything more in that column, or anything more in that, or sorry, row. I don't have anything more in that column, so this spot is done. I don't have anything left in this row to fill, so that means this row is done. So I'm done with my top row. So I go back and I reset. Now I'm looking at the second row. I'm going to compare it to the first column. So the row times the column. Again, you always go to the leftist number and the highest number. So put your fingers there. Fingers there. No, not up here. On there. Fingers on your papers. Fingers on your 3 and on your A. Okay? Then you're going to do 3 times A, and then you're going to do 4 times C. Drag it to the right, drag it down. 3 times A, 4 times C. Move your fingers, okay? There's a lot of science behind touching something, your brain making connections with your eyes. There's a lot of power there. Okay? So 3 times A, of course, is 3A. 4 times C, of course, is 4C. And then we would add those. You know, just like you asked earlier, Brian, if they were numbers, we would actually do the math. Right? We can't take 3A plus 4C. But if it was 3 times 2 plus 4 times -1, then we would do the addition. Okay? But I just don't want you guys to lose track of where the numbers are coming from. So that's everything in that row. That's everything in that column. So that means that spot is done. So I'm going to go to the next column. Okay? Again, the leftist number will always multiply the highest number. So 3, the first one in the column row multiplies the first one in the column. The second one in the row multiplies the second one in the column. The third one in the row, if there was such a thing, would multiply the third thing in the column. That's why the rows here and the columns here have to be the same size. Okay? So 3 times B, of course, is 3B. 4 times D, and then you would add those. Again, if those were numbers, you would actually do that addition, and then your answer would be written here, smaller. But we're not going to, we can't actually do anything. So you would have a number, a number, and a number. But it really is about just getting the motion, guys. You slide to the right, you need to slide down. Okay? And that little twist. Okay? First thing you do is check the dimensions. 2 by 3 is 2 rows, 3 columns. I can't add these. Right? Again, we're losing a little bit of that, Brian, that I can't do that step. But I want you to make sure you understand where the 3 and the B came from. Like this 3 gave you that, and that B went here. I can't actually add those. Again, if that was like 3 times 2 and then 4 times -1, I'd have 6 and -4, then I would add them, put that there.
So there's like 1A, 2A?
Yeah, but you guys won't have variables. Okay? I'm just doing this so you can see where the things came from. So yeah, you don't need to worry about that. That's a 2 by 3. Next one's 2 by 3. So they're the same size. That doesn't matter. What matters is, are those the same? They are not. This problem is not possible. You cannot multiply those 2 matrices by each other. Right, so here's our actual first problem. We're going to see how it all actually goes together. Okay. First thing you check. 1, 1, 2, 3, 4. So it's a 1 by 4. 1, 2, 3, 4. So it's a 4 by 1, 2. 4 by 2. So this problem we can do, and the answer will be 1 by 2. It's kind of strange. We could take a 1 by 4 matrix and multiply it by a 4 by 2 matrix, and then we get this 1 by 2 matrix. Our answer physically is going to be much smaller than the 2 pieces that put together. Right? It's kind of strange. So I have a 1 by 2 matrix, 1 row, 2 columns. So I go to set up my work matrix, 1 row with 2 columns. Okay. 1 row, 2 columns. I take that whole row. I'm going to multiply it by the whole column. Okay. I want you guys just to watch. Put your pencils down. Okay. I just watch how things are moving. Okay. The leftist number, the first element here, is going to multiply the first element here. So -3 and -1, those are going to multiply. So I'm on the -3 and the -1, and I move one spot to the left, right? I move one spot down, so I'm on the 2's. And then I move one spot to the right, one spot down, so I'm on the 5 and the 1. And I move one spot to the right, one spot down, I'm on the 0 and the 5. Okay? I'm going to connect all these with lines. You guys should not do this. Okay? Those two are going to multiply. These two are going to multiply. These two are going to multiply. These two are going to multiply. Notice how the thing on the row slides to the right, the column slides down each time. Okay? Then each of those multiplications are going to add together because those are from the same row, same column. So they're all going to go into the same row, same column spot. They're just going to get added together. I only have 2 spots to fill here, right? That's why it's so important to set up your work matrix. I only have 2 spots to fill. I can't write a whole bunch of numbers all over the place. Okay? So 3 times -1. -3 times -1 is 3. Then I'm going to add that to 2 times 2, which is 4. I'm going to add that to 5 times 1, which is 5. I'm going to add that to 0 times 5, which is 0. We'll do that addition in a second. I'm not going to do it right now. But there's the last thing in the row times the last thing in the column, which means this spot is done. Now I move to the next column, which means I needed to move to the next column. Okay, how do you know when to move on? Okay. Now I'm going to take everything in this row times everything in this column. The very first thing times the very first thing. So -3 times 4. -12 plus. Now I'm on the -3, move 1 to the right. On the 4, move 1 down, so I'm at 2 and 0. 2 times 0, of course, is 0. Plus. Go from the 2 to the 5, go from the 0 to the 3. 5 times 3. Plus. On the 5, I go to the 0. On the 3, I go to the -2. So 0 times -2. That's 0. Now I worry about the answer, right? Now I'm done. All my spots are filled. I did one row times both columns. That's all there was. Now I go and do that addition. 3 plus 4 is 7, plus 5 is 12. 12 plus, or -12 plus 15 is 3. So there's our product. So that matrix times that matrix gave us this as our answer. That's the answer. That's the answer. Yeah, Aiden asked if there's anything to do with the 12 and 3. That's just the answer. That matrix times that matrix gives us this matrix. Okay? Remember, these are not systems of equations. These are not augmented matrices. Okay? We're not multiplying one set of equations to another set of equations. That's not what this is. This is purely like you would use this to take a set of data or a set of values that you have for whatever reason and multiply it by another set of values that you have. Okay? Again, a lot of business applications here. Okay? If you have a set of things you need to buy, and then costs at different points or something like that. If I buy it on Tuesday, it costs this much. If I buy it on Wednesday, you could set things up that up. But yeah, it's a lot of business applications for these things. Again, it's all computerized now, but somebody has to write those computer programs, and people will always be writing computer programs. For the foreseeable future, there's always going to be another program coming out that's going to be better than the last one. Somebody's got to make those things. Not saying you're going to do that, but it's something that could be a job of yours someday. All right, so first thing you do, add dimensions. 1, 2, 3. 1 by 3. 1, 2, 1. 2, by 1. What's that mean? Not possible, right? You gotta move on. What do you guys notice about E and F? What do you guys notice about E and F? Right? They're same two matrices, but in opposite order, right? Well, now I have 1, 2, 1, so a 2 by 1 times a 1 by 3. So what happened? It's possible now, okay? Oh, that's why they do that, right? So what this is trying to show you guys is that matrix multiplication is not commutative, okay? Normal multiplication is commutative. 3 times 4 is the same thing as 4 times 3. It doesn't matter what order we multiply in, we'll get the same answer. Not only does matrix multiplication not necessarily, like if I take matrix A times matrix B, I get my answer, then I take matrix B times matrix A, I may get a completely different answer, or the problem may not be even doable when I switch the order, right? So here we saw one way it wasn't even possible, the second way it's possible, but if it turned out they were both possible, you wouldn't necessarily get the same answer, okay? So matrix multiplication is not commutative, which means it's important that you pay attention to what order you're doing things in. Just like division is not commutative. 2 by 3 is not the 2 divided by 3 is not the same thing as 3 divided by 2. All right, and 0 divided by 3 is not the same thing as 3 divided by 0, and 3 divided by 0 isn't even possible. So division is not commutative. Okay? Matrix multiplication is not commutative. So our answer is going to be a 2 by 3. This problem is going to be pretty similar to the very first problem we did because of the ones. There's not going to be a lot of work to do here, okay? So it is something that you can pay attention to if you want, that just knowing that there's not going to be a lot of work. There's going to be a lot of little individual problems, but not ones where we have to do addition. So I need to set up a 2 by 3 work matrix. So 2 rows with 3 columns. So 1, 2, 3, 1, 2, 3. So there's a 2 by 3 work matrix. And now I go back to the problem and say I need to take this row, which only has one thing in it, times this column, which only has one thing in it. So I don't have a way to slide over to the next number. I don't have a way to slide down to the next number. So 2 times negative 3 is the only thing that's going to go up here. That's everything in this row times everything in this column is what goes here. Okay? So since I can't move right, I can't move down, that means I'm done once I do that thing. Okay? So that's negative 6. Well, now I want to go to the next column. So that means I'm going to go to the next column in my second matrix. So I'm taking that 2 times the 4 now. So 2 times 4 gives me 8. That's everything in that row times everything in that column. So I slide to the next column. So 2 times 1, which of course is 2. So that's that whole row times all of the columns. I don't have any additions to do here. And so since that top row is now filled in my answer or my work column, my work matrix, sorry, that means I slide to the next row of my first matrix. So that row times that column. So 5 times negative 3 just gives me negative 15. But I'm done there. I can't slide to the right anymore. I can't slide down anymore. So now I do 5 times 4. I can't slide to the right. I can't slide down. So that means I'm done with that spot. So I move on to the next column. 5 times 1. So you guys could leave it like that, or you could, kind of clean it up if you want. So that'd be negative 6, negative 15, 8, 20, 2, 5. So squish it down to be a more manageable size. But I would always start big if I were you guys, okay? Because you aren't necessarily going to know like how much work you need to do first. So just go ahead and give yourself a lot of space. And then if you don't need it, you don't need it. But if you turned out to need a whole bunch of space and you haven't given it to yourself, you're kind of screwed. So just start with big spots and just see what happens. It's like, here on this problem, we needed a bunch of space. That was because of these fours. So there is a way to kind of know ahead of time if you really want to look into it. This will kind of tell you how much space you need. I need a bit of space because I'm going to have 4 things to add. I don't need so much space because I only have 1 thing to add, but that's not really anything you guys need to really be worrying about. If you just go ahead and just give yourself a bunch of space, you'll be fine. So I want you guys to, go ahead and try a couple here. See how it's working for you. Does it work out, Caleb? Did you get the second one?
Yeah.
Same? What did you guys? Don't try to rush yourself, guys. Okay? Work on it and compare. Copying isn't going to do any good. So work on it and see if that's what you're getting. Okay? You got it. It's all about getting that motion down. Okay? Copying isn't going to get the motion down. Making those mistakes and then fixing the mistakes is where it's going to get, the learning happens.
Yeah.
How you guys doing home? Clean up with Okay. All right, so last thing here, I want to show you guys how to use this calculator that can do that. All right, I showed you guys how to use a RREF calculator. I'll show you guys how to do a matrix multiplication calculator. So in your Google class, so I have to switch to my internet because if I do it on my iPad, it tries to make me download an app. So in your Google class, you should have a link to this calculator. Somewhere I'm hiding that thing. Where did I put it? Here it is. Share this screen, all these little steps. So the first thing you still have to do is find the dimensions of your matrices. Okay, you have to know if the problem is doable, and you also need to know the dimensions anyways. Okay. Oops, that's so you're hitting the share iPad. Share screen. There we go. So looking at number 1 there on the back side, how big is the first matrix? Nope, that's not what I'm asking. How big is the first matrix? 3 by 2. Okay, so then you go up here, you find the little 3 by 2 button. So 3 by 2, click. How big is the second matrix? 2 by 3, right? The 2 and then the 2, right? So then the 2 by 3 button. So make sure you come over here, click. You're going to type in the numbers. Of course, you need to be careful with your typing. It's easy to mistype. But then after that, you're just going to hit go. It'll do the math for you. Okay? This is how you use it. Here's the. Okay, you're just gonna have to, you have to look at the dimensions first, but then just type it in. Okay? So, yeah, that link for here, this is on Google Classroom. So, 7, 3, -2. But so on your worksheet for tonight, I'm gonna ask you guys to do a couple by hand. There's nothing stopping you from checking in with the calculator, but we want you to try a couple by hand, and then just try a couple with the calculator. Okay? So. Say go, it thinks for a few seconds, okay? Does all those little calculations that you were just doing, okay? And then it spits out your answer right there. Okay? But I do want you guys to try a couple by hand. I do want to see your work matrix. When you guys are doing the ones by hand, I expect to see this piece of it, not just the answer. Okay? So no, on the calculator, all you have to do is just give the answer, all right? But if you're doing it by hand, I want to see this and then this. And you guys can't see what I'm pointing at. Okay? So I expect to see this and then this. Okay? This and then this. You know, there are the ones that there is no work to do, like these. If that pops up, I'm not expecting you to do any work that doesn't exist. Okay? So, but if you have a simple one like that, you certainly don't have to show any work. Okay? So, all right, make sure you're turning your homework in from earlier in the week. Remember, we have one more day of this unit, Monday, and then we'll be working on taking the quiz, you know, probably next Thursday. So, and remember, anything you're trying to do from that unit 6, this is the, you know, the end of times for that unit.